Starting with few minutes. Sir, please proceed further.
Good morning to all of you. The topic of the session is higher order CFA. Uh, so I'm going to start the session. So let me explain the background of higher order CFA. The story started with the reliability and validity. So there are two concepts in the research. One is known as reliability and other is known as validity. So the CFA is the outcome of that. So we have to understand what is the because the topic is of again half an hour, so I have to explain each and everything in detail. The reliability means actually, even there are different type of reliability. So we normally divide the reliability in three categories. The reliability which depends upon time, the reliability which depends upon the cross section, and the reliability which depends upon the expert's consistency. So we have three kinds of reliability. So if we see the reliability with respect to time, this is called and retest, test and retest reliability. For example, if you measure your weight on a weighing machine, you want that the weighing machine gives you equal weight every time. Or if you conduct experiment at different point of time, so you want that the same result will come again and again, again and again. So if you are getting the same result again and again, right, this is called test and retest reliability, right? There are even in the questionnaire side, if you ask the same question to the same respondent again and again, you are expecting the same answer. So this is called test retest reliability. The test retest reliability is mostly applicable in the area of experiment, especially with the machines. Because if you are testing a software, if you are testing some experiment, so you have a desire that same result comes again and again. So this is called test retest reliability. But let me give one example to you. In India, though every wife asks the husband that how you like the food, right? Whenever she prepares the food, she always asks the husband, "Sir, how you like the food?" So this is the same question she asked to the same person, and the question is asked different point of time, right? So and you may not believe the answer is same. So every time the husband is saying the food is very tasty, right? So can we say it is a test retest liability? There are many examples like that, and answer is yes. The the this is the example of test retest reliability. But if we go to the research, normally we don't do this kind of thing. But in longitudinal study, so when you conducted a longitudinal study, in a longitudinal study, we have the same participant and we measure the same thing again and again. So test results retest reliability has its own importance. But the problem in test reliability is that as I'm saying you, giving you one example, when wife asks the husband how you like the food, and she also know what is the answer, and the husband also know what is the answer. And every time he is speaking lie. Right. This is the problem. So the problem with test retest liability is that the answer is same, but answer is false. every time the answer is same, but answer is false. So that's why we are moving to some other test. Similarly, if we go to the second category of reliability, the second category of reliability is the uh, consistency reliability. Consistency against the cross section. So because we are asking the questions to many participants, so we want that the relationship between different variables should be same. Like for example, if we are asking about the employee commitment, motivation, so we expect that anybody who is more motivated is also committed. So the relationship between the two variables should be same. This concept is called consistency, and this concept we carry on to the validity side. So what is consistent? What is consistent reliability? The consistent reliability is based on the relationship between the variables. And if the relationship between the variables is high, then we can call it consistent reliability. And consistency reliability is measured with the help of Cronbach alpha. So we are having split half alpha and Cronbach alpha, Gutman measure. So there are different measures of consistent reliability. The most popular measure of consistent reliability is known as Cronbach alpha. Now, if you see the formula of Cronbach alpha, the Cronbach alpha depends upon two things. Basically, those who are mathematicians, they know that the Cronbach alpha depends upon two inputs. Number one, how many items, how many statements you are including in the factor. Because we always calculated the Cronbach alpha of the items, statements, or the factors. So how many statements are there in the factor? You calculate the Cronbach alpha of the factor. Now, some factors have three statements in the factor. Some factors have five statement. Some factor have 10 statement. Some factor have more statement. So the Cronbach alpha actually depends upon the factor. So let me show you the formula for Cronbach alpha so that you can understand this. Okay. So if you see this formula, the internal consistency reliability, the internal consistency reliability is measured by the alpha, and the formula of alpha is equal to n into r upon 1 plus n minus 1 r. Now the problem with this alpha is that if n is high, the alpha will be high. If average correlation between the variables are higher, the alpha will be higher. So that's why whenever your number of statements exceeds in the factor, the Cronbach alpha have a tendency to increase. So and second thing, the average correlation, if average correlation is high, it means the alpha will be also high. Now here I am telling you some of the conclusions. So let me open the paint. Okay. So now I'm explaining you like this. The alpha is equal to n r bar upon 1 plus n, something like that, because formula 1 plus n minus 1 into r bar. 1 plus n minus 1 into r bar. So now alpha is directly proportional to n and R bar. So it is affected by these two things. So because of this problem, what happens when your N is high, the alpha will be high. Number two, when average correlation is high, the alpha is also high. So now I'm telling you one thing. If you are using a 5-point scale versus if you are using a 7-point scale, the alpha is high for 5-point scale as compared to 7-point scale. So this is one problem I found, and because of this problem, we have another problem in the SAM model. So SAM model do not support this 5-point scale. SAM model supports the 7-point or 9-point scale. So this is one of the reason that why we should not use the 5-point scale. Okay. So this is the outcome of alpha, because alpha leads to validity, alpha leads to biasness. So there are so many problems which is coming from the wrong alpha. And the another problem of alpha is that so if alpha is more than 0.9, it means your responses are redundant. So it means your responses are redundant. So that is another problem with respect to alpha. And when your responses are redundant, it means there is a lot of biasness in the responses. So there is a lot of biasness in the responses. So alpha is something which we have to take care very carefully. And the problem is that alpha is also the part of the validity. So I will explain this later on. Now, I hope you are having clarity on the alpha. Okay. Now, the third kind of reliability is called inter-rater reliability. The third kind of reliability is called inter-rater reliability. So when they are experts, so when you are collecting the data from the experts, you want to know the consistency in the expert's decision. You want to know the consistency of the expert decision. So that is called inter-rater reliability. Inter-rater reliability consistency is measured by there is a measure called kappa. So kappa is measuring the inter-rater reliability. So kappa is measured only when you are collecting the data from the experts. Otherwise, this is not coming. So after understanding the reliability, I'm telling you one more basic difference between the reliability and validity. Suppose there are 3 diagrams, and this is the bullseye. Okay. Now in this diagram, this is the false reason, and this is true reason. In all the diagrams, so this is false reason and this is the true reason. In this case, if you are getting the responses like this, right, and the second case you are getting the responses like this, and in third case you are getting the responses like this. So these kind of responses are known as not reliable and not valid. This kind of responses is called, because every time you are getting the same response, but all the responses are false. So this is called reliable but not valid. In this case, we can say it is also reliable and also valid. So actually, in the research, we are expecting this kind of response. We are not requiring this kind of response. We require this kind of response. So every time you need reliable and valid responses. So we can conclude, we can take a very important conclusion from here, that reliability do not leads to validity, but validity implied presence of reliability. So this is the connection between the reliability and validity, because we are going to talk about the validity in the session. So this point is very, very important point. So presence of reliability do not leads to validity, but validity implied the presence of reliability. If your data is valid, if your instrument is valid, it means it is also reliable. So therefore, you have to check the validity. Reliability is not sufficient in itself. Reliability is not sufficient in itself. You have to check for the validity. This is very, very important. Okay, now we are moving to the validity. So let's see the validity now. Now the validity of different types. So first of all, you have to check the phase validity. And even before that, you have to check the content validity. Content validity. After that, you have to see the convergent validity. Then you have to check the discriminant validity. Then you have to check the external validity, or external validity out of two types: concurrent validity, con con concurrent, current, concurrent validity, and predictive validity. And then in the last, you have to talk about the nomological validity. Nomological validity. So all these types of the validity we have to discuss in the paper. So let's start with content validity. Content validity means whatever you are asking, whatever you are measuring, is it right statements? Are you using the right statement? Are you using the right construct in the questionnaire? If yes, then it is called content validity. If not, it is not the content validity. So, for example, for every paper, you normally go for questionnaire, you are using different statements, you are using different factors. So the question is that how you can say you are using the right statement, right factors, how you can say. So for that, you have to show the literature support. If you have the proper literature support, then it means your content validity exists. In case literature support is not available, then you have to show that the expert validation. So you can validate your questionnaire and all with the help of experts. So this topic, this concept is called content validity. So validation of the statements, and the validation of the construct, validation of the factors which you are using. Second thing, what is the phase validity? Phase validity means whether your questionnaire statement are understood by the customers or not. So whether your respondent, okay, give me a minute. So I just want to know. Just So phase validity indicates that whether your respondents, and whether your the people from where you are getting the data understood the factors, understood the meaning of the statements, understood the language used in the questionnaire. So if yes, then it is called phase validity. So we normally conduct the pilot survey. The purpose of pilot survey is to check the phase validity of the questionnaire. There is no test to examine the phase validity. Only thing you need to check whether we need to change the language of the questionnaire, we need to add more questions in the questionnaire, we need to drop some statements or not. So that all everything comes in the phase validity. After that, now the today we will discuss more on this. So I'm going to discuss this later on because my whole lecture will be based on this. Let me explain these concepts because I'm not going to discuss more on these. So just explanation. Now the question is that whatever result you draw, whatever conclusions you are drawing from the research, how much they are applicable in other areas, other part of the country or in other part of the global. You see, suppose you say that this is my conclusion on online shopping, or this is my conclusion on the customers, this is my conclusion on the respondent. So can you expect the same conclusions if somebody conduct the experiment or research in USA, Europe, Australia? Are you expecting the same result also there? If yes, then it is concurrent validity. So because it is now external to your research, outside to your research. If you expect the same conclusion at any different part of the global, different part of the country, or different part of the international, right? So then it is called concurrent validity. Concurrent validity is outside with respect to place. So here we are talking about the whether your research is valid at a different places or not. Now, if you go to the prediction, now my simple question is that how long your conclusions are valid? So it is according to the time. So can you say your results are also valid 5 years after 5 years, after 10 years, after 15 years, after 20 years? So for how long your results may be may be valid, may be applicable? For how long your result may be applicable? So that is called predictive validity. Now after that we are having nomological validity. Nomological validity means are your results are satisfying the so, do you think that your results are satisfying the existing theory? If yes, then this is called nomological. Otherwise, it is not nomological. So, in the research paper, if you see any good research paper published in A category or A star category, they talk about each and everything. The researcher or the authors talk about from starting from the content validity, they finish to the nomological validity. So only construct validity is not sufficient in itself. You need to discuss about the content validity, phase validity, and concurrent validity, predictive validity, nomological validity. So directly or indirectly, you have to discuss the all type of validity. So that's why the knowledge of different type of validity is very important for a researcher. Now let's go to the next part. So as I told you that my lecture is based on construct validity. So let me explain the concept of construct validity. Construct validity. So there are construct validity of two types. One is called convergent and the second is known as discriminant. Discriminant validity. So what is the meaning of convergent validity and what is the meaning of discriminant validity? So let me explain you that. So first of all, I am going to discuss about convergent first. Now the convergent validity, suppose there is a construct and this construct is represented by It is a reflective construct because for formative construct we don't check convergent liability. For this concept is only applicable for reflective construct. This concept is not applicable to convergent validity. Formative construct. Only reflective construct is applicable for convergent validity. Now suppose this is a construct X and it is measured by three statement X1, X2 and X3, right? And the relationship between X1 and X, X2 and X, X3 and X is measured by lambda. Lambda 1, lambda 2 and lambda 3. So what is here? What is the lambda here? Lambda is known as the construct loading. So what is lambda? Lambda is called construct loading, and it is actually the correlation between item and construct. The correlation between item and construct, right? So this is the meaning of lambda. Now the question is, do the items significantly represent the construct? So we want to know that whether are these items are significantly represent the construct. So this is the question, and this question is answered by two things. Correlation, number one, between the items. Second, between the items and the constructs. So this question is answered by two things. So whether items are correlated among themselves. So whether the items are correlated with among themselves, and whether the items are correlated with the construct that is represented by the lambda. So we want these two answers. So whether the correlation among the items between the items are strong, and whether the correlation between items and the construct are strong. So the first concept is measured by lambda, and second concept is measured by this is not lambda. Sorry. So let me make a space for next. Now I'm saying that I want to know two things: whether the correlation between items is strong, whether the correlation between items and construct is strong. So I need to identify two things. So this answer is given by between the items, the CR and AVE. And items and construct is represented by the lambda. So there are three measures which answers my two questions. One is CR and one is AVE. This is the answer of one, and the answer of second is the lambda. But what is the problem? I'm telling you, this is a basic problem in the research, and it is still not rectified, that both are depends upon lambda. So CR and AV also depends upon the lambda. The problem is that. So everything is lambda, right? So now how CR and AV depends upon the lambda, I'm telling you. The CR is equal to summation of the lambda square and summation of the lambda square plus E square, right? So you know that the CR also depends upon the lambda. Similarly, AVE, if we check the AVE is sigma lambda square plus sigma E square. So AVE also depends upon the lambda. So the problem is that the whole convergent validity depends upon the lambda. The complete convergent validity depends upon the lambda. So let me explain something in more detail. So now I'm saying that there is a construct X. This construct X is represented by X1, X2, and X3. And this is lambda 1, this is lambda 2, and this is lambda 3. So first condition is that if lambda is greater than 0.7, lambda I is greater than 0.7. So this is the first condition. This is the first condition of convergent validity. So it means the item is highly or strong. The item is highly correlated with the construct. Right. So this is the first condition for convergent validity. It means all the items are significantly correlated with their construct. The second is composite reliability is greater than 0.7. It means items are highly correlated with themselves. So items are not only correlated with the lambda, items are also correlated with among themselves. So each items are correlated with itself also. This is correlated with this is correlated with this is correlated with this. So items are highly correlated among themselves. The third condition is that AVE is greater than 0.5. So AVE is like a R square. R square. In regression, we have the term R square. So AVE is like a R square. It means how much the constructs can be explained by the items. So how much the construct can be explained by the item? So the answer is minimum 50%. Minimum 50%. If items are not explaining the construct by 50%, it means we don't have the presence of convergent validity. So we have 3 points to check the presence of convergent validity. Right, now let's talk about something more.
So please explain third point again.
Yeah. So I am saying that because AVE depends upon the lambda square, right? The CR depends upon the lambda. AVE depends upon the lambda square. So whenever we explain the lambda square, it means how much these 3 items explain the variance of construct, right? So how much the construct can be explained by the items, and we want that at least 50%, because if you see the square of 0.7 is 49%. The square of this is 49%. But if you take 0.704 or something like that, the square is 50%. So if the CR is equal to 0.7%, 0.7, it is 0.7, right? Then AVE should be greater than 0.5, right? Because it is a squared sum of the lambda. So this is the condition that if average correlation with the items and the construct is 0.7, if the average correlation between the items is 0.7, so it means they are explaining at least 50% of the variance of the construct. So this is the case of AVE. I hope it is clear.
Yes, sir.
Okay. Now I'm explaining the next thing. This convergent validity. This convergent validity is applicable only for reflective construct, not for formative construct. It is not applicable for formative construct. Number two, also applicable for higher order construct. Higher order construct. It is also applicable for the higher order construct. Like for example, second order, third order, and all. So today we will talk about the second order only, not third and fourth order. Second order, because in research we always used second order, so that is very common. So convergent validity also applicable for the higher order, for example, second order, right? So these 2 points we have to take care of. And one thing I am also telling you, suppose you are having the second order construct. Like suppose this is the construct, this is y. Y is measured with the help of two constructs. This is x and z. X is measured with the help of three items. Item number 1, item number 2, item number 3. And z is measured with the help of four items. Item number 1, 2, 3, and 4. So this is x1, x2, x3, y1, y2, y3, and y4. So this construct is known as second order construct. Now, whenever you go for the convergent validity of it, convergent validity. So in this case, in convergent validity, the conditions you can check. Suppose this is beta 1 and this is beta 2. This is lambda 1, lambda 2, lambda 3, lambda 4, lambda 5, lambda 6, lambda 7. So the first condition of convergent validity in a second order is that all lambda I, or you can say average lambda I, should be greater than 0.7. Number 2, beta I should also be greater than 0.7. Number 3, CR, and here CR depends upon the beta 1 and beta 2, not lambda, should be greater than 0.7. And fourth condition, the average variance extracted, which also depends upon the beta 1 square and beta 2 square, depends upon, should be greater than 0.5. So this is the condition for the convergent validity of a second order construct. So we will also check this, whether our construct is second order or not. So if you want your second order to be a valid construct, so you have to prove the four conditions, and then you can say my second order construct is having the convergent validity. So this is the point that we are applying from the zero order construct to the second order construct. I hope it is clear. Yeah.
Yes, sir.
Now we are moving to the next. Okay, don't save. Now the second case is the discriminant validity. Discriminant validity. Discriminant validity is applicable for the reflective construct and formative construct also, but not applicable for higher order. Not applicable for higher order. For a single higher order construct. Higher order construct. However, applicable for a mixed scale. Mixed scale. Mixed scale means where some of the constructs are higher order, some of the constructs are zero order, then it is applicable for mixed scale. So there is a confusion. There's a lot of confusion in the researcher that how where we should apply discriminant validity and how we should apply with discriminant validity. We are using second order construct. Should we go for discriminant validity? So there's a lot of confusion. So I'm telling you, Discriminant validity is only applicable for the reflective, formative, and the mixed scale. It is not applicable. It is not applicable for a single higher order construct. So this point you should know. Now let me tell you how to measure it. Now suppose I have three zero order construct here, x, y, and z. And x is measured by three items, x1, x2, x3. Y is measured by again some of the items, y3, and z is also measured by three items, let's say z1, z2, and z3. Right? So this is a measurement scale. This is what? It is a questionnaire. In this questionnaire, we are asking the three construct with the help of 9 items, and this questionnaire is known as measurement scale. This questionnaire is known as measurement scale, and this model is known as measurement model. So when we examine the questionnaire, validity of a questionnaire by a model, this model is known as measurement model. Now what we want here? So we expect two things here. Number one, the correlation between items of similar construct or same construct should be high. Answer is less than more than 0.7, right? So correlation, suppose correlation between all the three, correlation between y, correlation between items of z, individually they should be greater than 0.7. But correlation between items of different constructs must be low, and the maximum limit is 0.7. So now what I'm saying that if you see the correlation between x and y or y and z or x and z, the correlation between the items of two different construct or three different construct is having the maximum limit of 0.7, and according to the international scale it is 0.5. They should not be greater than 0.5. So this condition is known as discriminant validity. So this condition is known as discriminant validity. Now the question is how to measure it, how to measure the discriminant validity. Okay, so how discriminant validity can be measured? Discriminant validity measured with the help of one is Fornell-Larker criteria, Larker criteria. The second is HT-MT ratio. Then simply by cross loadings. So there are three measures of the, one more. Comparing the AVE versus MSV. So there are four measures of discriminant validity. So these are the four criteria of examining the discriminant validity. So I'm going to explain you all the four. Okay. So first of all, let's explain these two, and then I will go to these two. So let's say we are having three constructs. This is X, this is Y, and this is Z. X is measured by X1, X2, and X3. and y is measured by y1, y2, and y3. And if we check z1, z2, z3. So correlation between any x or xi and yi summation. This is average correlation, or not summation, average correlation. Average correlation between items of x or an items of y should be less than 0.7. The average correlation of x and average correlation of z should be less than 0.7. The average correlation of y and average correlation of z should be less than 0.7. So how you calculate it? So the correlation between x1, y1 plus correlation between x2, y2. Sorry, x1, y2. The correlation between x1, y3 plus correlation between x2, y1 plus correlation between x2, y2 plus correlation between x2, y3 plus correlation between x3, y1, x3, y2 plus x3, y3. So if you take if you divide all the correlation by 9, the average correlation should be less than 0.7. So normally we don't calculate it, but conceptually, the items of any one construct should not be correlated with any other, right? So in this case, in this particular case, we are having three cases: number one, number two, number three. So if we square all these values, if we square all these values and divide it by the three. So let me call it like this: rxy plus rxz plus ryz. If you square it and take the average of it, this is called average shared variance, ASV. This is known as shared average shared variance. So in early days we calculated this average shared variance, but now we are not calculating this average shared variance. Rather, we find out who is the maximum among all the three. So we calculate all these values and find out the maximum value against all the three, right? So that is called maximum shared variance. So maximum shared variance is the maximum value of all the three constructs, all the three measures, 1, 2, 3. So maximum value among all the three is known as MSV. So we calculate ASV and MSV and use this MSV value for comparing this value with the AVE. So now the picture comes like this. Now we are having three values: R, XY average square, R, XZ square, YZ square. So the maximum value of all the three, XY, XZ and YZ, is known as MSV, and we want that MSV should be less than AVE of X, AVE of Y, and AVE of Z. So this condition is the condition which is used in MOS software, and MOS is comparing the maximum shared variance with the average shared variance, and if the condition is satisfied, then we call it the presence of discriminant validity. So this is condition number one. Okay, I hope it is clear. Then the second is we want that AVE should be greater than any of the RXY, any of the RYZ, any of the RXZ. So AVE of X, AVE of Y, AVE of Z should be greater than all the three measures. This criteria is known as the Fornell-Larker criteria. But only thing is that because AV is a squared value, so we take the under root of it. Because AV is a squared value, and all the correlations are the correlations. So we have to take the square root of the AV. So if square root of the AV is greater than the correlation, cross correlation, so then this criteria is known as the Fornell-Larker criteria. This criteria is known as Fornell-Larker criteria, right? This is the most important criteria used for almost every research paper is using this criteria. Almost every research paper is using this criteria. So this is the most important criteria to be reported in the paper. Now I'm going to the, I'm telling you the fourth. This is the fourth is HT-MT ratio. Now suppose I'm telling you the HT-MT ratio. Suppose X is measured by X1, X2 and X3. Y is measured by Y1, Y2 and Y3. So I'm taking only two. So X1, X2 and X3, Y1, Y2 and Y3. So if we take the correlation value, so this box is showing you the correlation between X1 and X1, which is 1, 1, 1. And all other values are showing you the correlation between X1 and X2. Suppose it is 0.7, X1 and X3 is 0.8 because they belong to the same construct. X2 and X3, the correlation is 0.7. So this is the correlation between the same construct. Similarly, if you see this box, this is the correlation between RY1, Y1, RY2, Y2, and RY3 and Y3. This is the correlation between RY1 and Y2, correlation between Y1 and Y3, like that. Right? So these correlations are known as mono trait. Mono trait. So these correlations are known as MT. MT means mono trait. Now, if you see this correlation, this box. So this box I'm making slightly different. Yeah. So this box is finding out the correlation between X1 and Y1. X1, Y1. This is the X2, Y2, and this is the X3 and Y3. Similarly, like that. So this correlation, this is correlation is known as cross correlation. Cross correlation, and this cross correlation is known as hetero trait. Hetero trait. So we calculate the cross correlations and we calculate the same correlations or mono correlations. So mono correlations and the cross correlations, after calculating that, now we take the ratio. Right? So we take the ratio that the correlation between X and Y upon the square root of correlation between X and correlation between Y. This ratio is known as HT-MT ratio. So you can see that the hetero is coming in the numerator and mono is coming in the denominator. So this ratio is known as HT-MT ratio, and this HT-MT ratio is indicator of the discrete validity. This HT-MT ratio should be less than 0.8, but actually the book is saying this, but according to me, this HT-MT ratio should be less than 0.7 also. For a good result, this HT-MT ratio should be less than 0.7, not more than 0.7, or 0.8 is the maximum limit. And it is, if it is greater than 0.9, it means there is a lot of biasness in your data set. So your data set is not good. So you have to correct the biasness. Otherwise, you cannot have the presence of discrete validity in the results. So up to this level, okay. Now up to this level, I explained you the concept of convergent, all type of reliability, all type of validity. So I hope you are having now the knowledge of the reliability and validity. After this, we can go to the next part, next level. So if you have any query, Till now, you can ask.
Sir, can you please again explain in
Sir,
brief
good morning.
validity for higher construct, discriminant validity for higher construct?
We don't calculate the discrete value of the higher construct. I explained you that for a higher construct, discrete validity is useless. But if you have a mixed construct, if we have a mixed construct, mixed scale means some are higher order, some are zero order, then we can calculate the discrete validity. But for a single higher order construct, discriminant validity don't exist. Okay.
Sir, STMT ratio is equal to correlation of RXY under root divided by under root correlation of X and correlation of Y.
This is HTMT ratio.
Is the formula? Okay, sir.
Yeah. Okay, now,
Excuse me, sir.
yeah.
So, like, there are 4 ways to report the discriminant validity. So, what is the most commonly used, and do we always report it?
Fornell-Larker criteria is 100% available in any paper based on SAM.
Okay, sir.
And we never reported the cross correlation. We never reported that. And we also not reported the AVE and MSV. So the most important is the Fornell-Larker. And if you are applying the PLS, you can also go for the HTMT ratio.
Okay, sir.
Yeah. So whatever I explained you, I'm just showing you the slides with the help of the slides. And after that, I will move to the next level. So I told you the construct validity is having convergent and discriminant. And construct validity is measured by the composite reliability AV measured with the help of the lambda. And the discrete validity is measured by Fornell-Larker criteria. So you will have this kind of table by the software. And again, this is also the type of the result in HTMT ratio. HTMT ratio. So Fornell-Larker criteria can be represented by this. Like in formative, it is not applicable, but in others, you can measure it. So similarly, HTMT ratio is looking like this. And in short, we are having these two criteria to be reported in the paper. Okay, now we are moving to the higher order. So because the today topic is higher order CFA, now I'm focusing on that. Okay, so this construct is basically the zero order constructs. And this construct is known as first order construct. So this scale is known as first order scale, first order CFA. This diagram is known as first order CFA. This diagram is known as second order CFA. So in second order CFA, the construct is represented by 3 zero order construct, and these zero order construct are represented by the items. So for a second order CFA, the convergent validity is applicable, discrete validity not applicable, and high multicollinearity is desired. So you can see that the high, all the beta should be more than 0.7, at least average should be more than 0.7. And there is a rule of one, actually this rule is only applicable on the MOS, not in PLS. And this is another example of second order construct. And when you run CFA, you have to run this diagram and report it, the result of this diagram. Similarly, this is an example of second order mixed CFA. And in mixed CFA, you can see that this is one construct represented by 3 construct, second construct represented by 2 construct, the third second order construct represented by these 3 constructs. So we have different kinds of these scales, and similarly, okay, let me show you how to measure the validity of all these. So now I'm using the software to report it the validity. I will use first order first, then I will use second order, and then I will use for mixed order. So after that, you will have complete clarity on this topic. So this screen is already shared. So first of all, I am going to the MOS software. Okay, so let me open a blank file. So this is a blank MOS file, and I'm importing the data set. The data set, I'm taking the same data set which I gave you, training data set. So let's go for that. So the training data set in CSV format. So we have to check for CSV format. So I provided you the training data set. I think the software is not taking the in CSV format. Let me check once more, one more time, because CSV format is almost supported by all the softwares, but otherwise I will take it the SPSS format of the dataset. It is CSV training open, could not be opened for reading. Okay, so let me go for other dataset. So I have the same dataset in SPSS format, so I'm taking that. So now we are having the dataset in SPSS. This is the dataset. I'm importing the dataset, okay. And the files you can see here. All the files are available. And in this file, we are having 5 construct. In each construct, we are having 5 items. So this is the construct number 1. Actually, we always work on the construct number 1, and the rest of the construct we can use duplicate icon. So now I can use the duplicate icon 1, 3, and 4 and 5. So we are having the 5 constructs, so I'm using the 5. Now just drag and drop. Okay, so now I am going to the view interface properties. I want to remove the long sentences. So you can see that I by this command I can remove long
ये कौन
sentences.
बोल रहा ये तो सिक्किम की लड़की लग रही
And now I'm going to use the model. So now my model is ready. Okay, and I think this is not connected. Okay, so we can make this CFA diagram like this, and all the error terms we can fill from here. Plugin, name unobserved variables, and we have to name the variables because software will not accept these names. This is my management policy, and this is the selection policy. Similarly, this is my training quality, and this is the D is employee improvement, and the last is organization performance. Organization performance. So we have the total 5 construct in the measurement model, and I am going to check the validity of this model. So everything is done. Go to this analyze properties. So in the output, we want standardized estimates, squared multiple correlation, modification indices, test for normality and outlier, critical. No, this is not required correlation, and this is 40. So these are the output we require in the results, and then you have to save it. Otherwise, the software will not run the model. So save as. So let's save in the desktop so that I can delete after that. CFA. Now the model is ready. It is saved, and now we can run it. For running it, you can press this. Okay. So the model is ready, and go to the results. So what you have to see, number one, normality, that all the skewness and kurtosis should be less than 1. Here we are having problem here. Then estimates, all these are significant. The construct loadings are more than 0.7 in all the cases. That is good. And okay, after that, the model fitness, we have to check this. So let me explain each and everything. But first of all, I want to see the validity. So for validity, we use, now I'm going to, there is a software, there is a website, Stats Wiki. So I'm going to this website and I'm taking a calculator from there. So you can see that there's a calculator called Stats Tool Package. So I am going to use this calculator. I just click on this, it's saved. So this Excel file is very, very useful for SAM. And I am using this calculator. The first option is called Validity Master. The first option is called Validity Master. So I'm opening the Validity Master. So this is saying that you need 2 tables. You need to copy and paste 2 tables here. And then I will go calculate the validity. So I'm going to take this table, standardized regression weight table, and copy. So you just paste this table here. Then you can go to the correlations table, copy, and paste correlation table in A2, the table here, and just run. So here the all answer, composite liability, average variance expected, MSV, maximum RH, or so all the measures are calculated by the software in only one command. So now you can see that the how easy it is calculate the how easy it is to calculate the convergent and discrete validity, and software is telling you that there is no problem in the convergent validity, but you are having the problem in discrete validity in case of all the items. And software is also telling you where is the problem. Like in first case, the AVE for training quality is less than the MSV. The AVE for management policy is less than the MSV. So when this condition is not satisfied, the software say that there is a problem. So basically, we are comparing the AVE and MSV, and all the AVE are less than MSV. So condition is not clear. And if you see this table is known as Fornell-Larker criteria. This table is known as Fornell-Larker criteria, and in this table, all the values, all the red values should be greater than all other values. For example, 885 should be greater than all these. 873 should be greater than all the three. 835 should be greater than all the two. This value should be greater than all this value. But the problem is that no condition is satisfied, so we don't have the validity in the scale. So it means our scale is suffering from the problem of discriminant validity. Convergent validity is okay, but discriminant validity is a problem. So in this way, we can check the validity of the first order construct. So then we are moving to the second order. I think this is first order CFA is clear. Now let me show you the second order. So I already have the diagram. Yeah, the CFA second order mix. Yeah, in this case, you can see that I have second order mixture. We are having three second order constructs. Three second order constructs CR, BAT, and SQ, SC, and I want to compare. I want to check the validity of this measurement scale. So the model is already there. I think data is also already attached. Second order mix CFA. Okay, now run it, and the procedure is exactly same. You just run it. Go to the output, estimate. And I'm taking the standardize this table to the calculator. I'm pasting this, paste standardized regression table weight in F2. I pasted it, and then I go to the correlations. So I go to the correlations and run it. So you can see that we are having the problem in CR, we are having the problem with AVE. So it means our scale is not valid. Our scale is not valid, right? So the software is saying to you that the problem is there in the reliability and validity. So problem is clearly defined here. So this is the way we can check the reliability and validity of mixed scale. And let me also show you some other CFA model. Second order CFA, I am looking for this. Yeah, second order mixed CFA. Let me check this. Second order SAM. Okay, this we already tested. Okay, so let me make a second order construct. New file. So I'm showing you how to check the validity of a second order construct now. So I have to attach some file, and let me check where is the file. Okay, so in this case, this is a scale of the work-life balance. Work-life balance. So work-life balance is measured by this construct WPS, WILP, PILW, and SW. So these four constructs are the measurement of the work-life balance. So in first case, we are having the 1, 2, 3, 4, 5, 6, 7, 8 construct. So let me make 7 in each, 6, 7 or let me put 8. And rotate it. I have to make 4 different constructs so to be fit in the page. Okay, so let me duplicate it. 1, 2, 3, and 4. So this is WPS 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So all are perfect. This is a very famous scale of measuring work-life balance. Then we have work interface in personal life. WIPL means work interface in personal life. Okay. Then PLIW, personal life interface in work. This is called personal life interface in work. Okay, let's take only this. And this is SWLB. So full form I forget. Now it is only having the 5 statement. So this is a second order scale of work-life balance. And I'm going to check its validity. So if you remove this, then all items you can see very clearly. Okay, now I am going to make a second order. This is a second order construct. The name of the construct is work life balance. And we are measuring the work life balance with the help of 4 items like this. Okay, now go to plugin, name unobserved variables. You have to give name work personal interface. This is something like the WPS work place support. Okay, workplace support. This is workplace support. And this is work interface in personal life. Work interface in personal life. This is personal life interface in work. And this is something support. I forget the full form, so just write SWLB. Okay. Now my construct and model is ready. Okay. And one thing problem is that in this case I removed the 1, so I have to place. So why? Okay. Now you have to place 1 parameter, and you have to place. This is the rule of 1, parameter 1, and now I think it's perfect, and we can run it. So run it. The software is saying that okay, yeah, we have to put 1 error term in all the constructs. It is a rule of Amos that we have to put all the error term to the endogenous constructs. Okay, now we can run it. So this is almost ready. Plugin name unobserved variables. So this model is completely ready now to run and But first of all, you have to save it, because without saving, you cannot run this. Second order CFA. So this is second order CFA,
कॉन्फ्रेंस में वो चल नहीं रही है
and some disturbances coming from the background. Now I want the standardized estimates for this, and modification indices. So normally I tick on this, run. Okay. So we have the values here. Okay. So these are the 4 values we need to check. Yeah. So I am taking all the 4 values, because in second order CFA, we have to calculate each and everything on our own. The software is not giving you the result. So let me go for this. Okay. So I'm taking all the values here. The lambda is given to be 0.736, 0.533, and 0.577, and 0.397. Okay, this is the lambda. Then the lambda square. So I have to calculate the lambda square equal to this value square. So it is the squared value. Then this is the error term equal to 1 minus lambda square. So error term we calculate like this. And from these 3 values, I can calculate each and everything. Yeah. Now I calculate the CR. CR is equal to sum of all these values. Then we have to put square divided by, and then okay, rather than doing a long calculation, first of all, let's take the sum equal to sum of these values. We can take the sum of all. Yeah, now it is much better. So equal to this value square divided by this value square plus some of the error terms. It is so simple. We just calculating the value of CR, because we don't have any ready-made calculator for calculating it. So CR is 0.65. Then we can calculate AVE. So the AVE is equal to the this value divided by this value plus this value, and okay. So now the problem is that both the conditions are not satisfying the convergent validity for the second order construct. So we cannot use it as a second order, because in second order, the CR should be greater than 0.7, AVE should be greater than 0.5. Otherwise, your second order construct is not a valid second order construct. So the second order construct is not valid. This is the problem. And now I'm going to show you with the help of PLS software. And I'm not saving, okay. Now I'm going to the PLS and showing you the how to measure the validity of in PLS. So open the Smart PLS and going to open a new project, higher order CFA. And so the technique is different here. So I just select the data, and the data is available in the Smart PLS folder. Data set. I'm taking this work-life balance data, higher order data. So I think this is higher order data. Okay, so we have the work-life balance data set in this. So I am taking it. WPS. This is my construct number 1. And this is my construct number 2. This is my construct number 3. And this is my construct number 4. So all the 4 constructs are measuring the work-life balance. So let me make the model in a better way. First of all, I have to rename it, otherwise I am not able to see. WPS, and this is WIPL. Okay, and this is PLIW. And this is the SWLB. SWLB. So now we have to arrange it. And send it to the right. Okay. Now I am taking a latent variable, and this latent variable is actually the second order, and it is reflective. Okay. Now in second order, we need the item. We have to define this is called work life balance. And so I'm adopting the repeated indicator approach. In repeated indicator approach, we take the items twice. So this is my repeated indicator approach. And okay, so now my model is ready. My second order model is ready. All are blue, so you can run it. So after that, I am going to calculate the consistent PLS algorithm. Going to the calculation, and all the results are here. So let me check one by one. First of all, so work-life balance. So this is my second order and all are my first order. So here I am testing both. This is my average variance extracted. This is the composite liability. This is rho, and this is Cronbach alpha. So my work-life balance, the Cronbach alpha is fine. Composite liability is also fine, but there is a problem in my AVE. So one condition is fulfilled and this condition is not fulfilled. So that is a problem. It means our second order construct is not a valid construct, not satisfying the condition. So you know that how easy it is to check the validity of a second construct in PLS. So just in 5 minutes, you can run all the exercise. So in work-life balance, Cronbach alpha is good. Rho is good, but we don't include the rho in the analysis. Composite liability is good, but we are having the problem of variance extracted. So that is a problem. You can go for a VIF, and we have not seen any VIF because multicollinearity is required in this second order construct. But unfortunately, we don't have any multicollinearity. Then you can go for a discrete validity. In discrete validity, you are having Fornell-Largar, cross-loading, monotate, heterotate. But we are not looking for the second order. The discrete validity is applicable only on the first order. So when you see Fornell-Largar criteria, ignore this. When you go for cross loadings, so all the cross loadings, you can see the cross loadings is quite. So there is a chances of cross loading not very good. Yeah. Uh, PLIW is only highly correlated with PLIW, not correlated with any other. So cross loading is not there also. And if you click on the heterotrait, monotrait, this value is having a problem. And if you click on PLIW, not a problem. Only this value is a problem. As this problem. So if you click on all, so we don't have much problem in only except one. We don't have one, not much problem. So all the values comes in the quality criteria. So reliability and validity you can see from here. Discrete validity you can see from here. Collinearity statistics is analyzed from here, and outer loading can be analyzed from this. So PLIW all green. Then as this is some problem in the construct loading also. This is all green. This is only one red, all green. So we are having a problem in the work-life balance. You can see that in work-life balance, the construct loading is a problem. All low construct loading we are having. So the conclusion is that the construct is not valid as per second order construct. So we cannot use this construct as a second order. The condition is not satisfied by the model. And what happens if your condition is not satisfied? I am telling you, you cannot get the goodness of it in the MOS, and in PLS. You will have another problem in PLS also. So we will have the model fitness problem. We will have the path coefficient problem. We will have many problems if your second order construct is not valid. So in this way, we can check the validity of a higher order construct in smart PLS. So I think I have covered each and everything in related to the validity. Now you are having around 20 minutes. So you can ask your query. Okay, so I have demonstrated almost every kind of validity to you, and so this is the query session or discussion session. And if you have any query, you can ask.
Sir, often in some researches, instead of taking a higher order model, they take the first order zero order model and put model constraints on the factor. How much relevant is that?
This is perfectly relevant. There is no problem in doing that. Actually, it depends upon the hypothesis. Once you examine the validity that my second order construct is a valid construct, you can convert it into a zero order and can use in the SAM model. That is perfectly okay. There is no problem in it. Actually, like for example, suppose I want to check how the organization stress is influencing the work-life balance. So my objective is not to check the interrelationship between the zero order and the work-life balance. So my only objective is to check the relationship between stress and work-life balance. So I can convert the second order into zero order construct, but it is it is required that before doing that, before converting a second order construct into zero order construct, you must report it the validity of that.
Suppose in this case, if we are not having a second order construct in the example you gave, and we put it into zero order construct and put the model constraints and then fit the model, would that be applicable to use it?
So that is, I think you are talking about the invariance.
Yes, sir.
So invariance is different thing, because invariance is again another assumption. So we want that basically the logic of invariance is that your model should be valid for the different subgroups. Right. So yesterday I have discussed the invariance test, and the measurement invariance is almost compulsory for all the models.
Okay, sir. Thank you.
Participants, please ask the question.
Sir, and do we have any paper to cite for the thresholds for second order constructs?
Yeah, there are many papers.
You could just
And
suggest.
actually, if so I have to find out, because not ready with me. but I have seen this in many papers.
Sir, Dr. Ritu has written some thing on chat box. Can you see this?
Chat box. Okay, let me open the chat box. Ritu Sinha. Sir, you mentioned the repeated indicator for second order. Why? So because we only have this method in PLS, we don't have any other method. In PLS, we are doing it in this way only. So whenever you go to the second order modeling in the PLS, you have to follow the repeated indicator approach. There are only two methods in PLS. One is the repeated indicator approach, which 99% of the scholars adopted. There is another method, but nobody adopted that. So everybody is going for repeated indicator approach in PLS for second order, for higher orders. Even for the third order, you can do that.
Sir, would this process be same for a formative reflective construct? Where
Yes. Yes. Repeated indicator approach is this method is same for all repeated formative, formative, reflective, formative, formative, reflective, reflective, all.
We are waiting for you the questions. If you don't have, then we will conclude the session. We will wait for further for 1 minute.
Yeah, sure, sir. We can wait for 5 minutes, no problem.
Okay, sir. I don't think, sir, the participants have any question. So making the life easier for everyone because they would have missing something because the next session will be start from 11:15. So
Okay, so they want a break.
Venisha, do you want to ask suddenly?
Yes, sir. Yes, sir. I want to
Please,
ask one query.
please.
Good morning, sir. So my query is about second order construct. Suppose if we don't have items to measure second order construct, then can we go with the analysis what you have told, sir?
Actually, in second order construct, we never have the items. We
Okay.
only have the items of the zero order construct.
Okay, sir.
And we are measuring the second order construct itself for the zero order. The second order construct is not having any item.
Okay. Okay, sir. Thank you, sir.
Thanks.
The way you taught us the things make it really very easy for most of us who are practicing because the clarity which we was needed that was there. Thanks a lot for your such a great gesture, sir.
Thank you, sir. Thank you.
Thanks a
Thanks.
lot, and we will meet at 2:30 again today.
Yeah, sure.
So till the time we have one more session on mediation and moderation. The change is only for for making the people more comfortable because seeing the same face every time sometimes it makes some otherwise uh, if someone will ask to me, I will definitely give more session to Ajay sir because we are learning a lot from him. even he was not in the class, then we go to the YouTube and search his videos, and we are seeing that. So actually, live from Mumbai, he is with us, and that's a great gesture from the government also, that they have provided such a facility to us, and the expenses being incurred by the government only. So we have to just intact with the sessions and learn at as much as we can. Thanks a lot, sir, for your this session. We will meet again. So
Thank you, sir. Thanks.
participants, you can log out. We will log in again at 11:15, and we will conduct the next session. Feedback form is available on the chat box. Please fill within next 5 to 10 minutes. We will be available here. And if you fail to do so, we will close. Normally, we close the feedback form. So, and feedback form is not an attendance form. It's not an attendance form. Attendance will be automatically taken from the Google Meet. And I told you the rest of the things on the WhatsApp. So thanks a lot for your cooperation.
Sir, share the feedback, my feedback with me.
Sir, actually, this is not your feedback. This is the
Okay.
feedback. But I will share, inshallah. Whatever I have, I will definitely share.
Yeah, if somebody give the feedback on my session, so please share.
In the first session, we have 129 feedback. Out of those 129 feedback, there is an option where the participant can choose best two resource person. And out of those 129, 75 of the participant has chosen you as a best of the two of the resource person.
Okay, that's good.
You are the highly, acceptable and recognized. Rashmita, do you want to ask something? Rasmita Pradhan. Sometime it happens, sir, because the phone is not being handled properly, so the hand is being raised. Thanks a lot, sir. We'll meet again.
Thanks, sir.